In this video, I'm going to be talking about how tumors, how they form oncobiofilms, a protective layer, also how immune cells can play a role, also including how exosomes play a role as well. I've talked a lot about exosomes in my other videos, so if you haven't seen those, feel free to check those out. Now, here's where iron deficiency plays a huge role here, because under hypoxia, low oxygen state, which is caused by iron deficiency, um, this also includes reactive oxygen species. The cancer cells, they start secreting a lot of things, such as hyaluron, proteoglycans, mucins, galectin-3, and this matters because this is the seeding layer that sets the physical boundary of a future oncobiofilm. So that all of these things are secreted because or under hypoxia, which is iron deficiency. A good way to help increase the macrophage exporting of iron, because if iron is hoarded or trapped in macrophages, that's going to lead to hypoxia. So the ferroportin has to export the iron. A good way to reduce hepcidin, which is what is degrading the ferroportin, is to lower IL-6 with fruits. A variety of fruits can reduce IL-6. Therefore, hepcidin cannot degrade ferroportin, so that the iron is not trapped in the macrophages. Because if the iron is trapped in the macrophage, then that is what is leading to iron deficiency. Therefore, the hypoxia that is driving the oncobiofilms. So tumors, they also recruit CAFs, short for cancer-associated fibroblasts. What they end up doing is that they turn the matrix from a soft slime to a stiff glue-like EPS. Also with LOX, lysyl oxidase. And this has to do with a stiff biofilm. Okay, so immune cells, they get trapped and contribute polymeric debris, which is going to help form stronger EPS, which is linked to biofilms. So there are neutrophils and macrophages. They release nets. Also, exosomes. Also, they release DNA and even cathepsins. So that they all end up forming a stronger EPS. Okay, so tumors, they also remodel the matrix by secreting MMPs, MMP2, MMP9, which break down the ECM, which is what biofilms need. And this generates sticky fragments from the ECM that behave like EPS polymers. And these polymers, they end up forming a matrix like a biofilm. Okay, in biofilms or oncobiofilms, polysaccharides, they cross-link with eDNA, which was secreted earlier by either tumors or immune cells. And in oncobiofilms, cross-linking happens to be driven by exosome surfaces, also by mucins and galectins, but I'll be focusing mainly on the exosomes here. Okay, the reason the tumors got the exosomes in the first place to form biofilms is that the MVB sacs, they fused to the plasma membrane. The MVB sacs contain the exosomes. So the goal is to get the MVB sacs to fuse to the lysosomal membrane instead of the plasma membrane. Because if the MVB sacs containing the exosomes fuse to the lysosome, then the tumors will not get the exosomes and the tumors cannot form biofilms. A great way to help the MVB sacs loaded with the exosomes to fuse to the lysosome is to prevent lysosomal membrane peroxidation. Because if the membrane of the lysosome is peroxidized, cathepsins will actually leak or escape out. And cathepsins are required inside the lysosomes. The cathepsins have to stay in there so that the cathepsins can degrade the exosomes once the exosomes are taken up by the lysosome. Now, I've explained this process in a lot of my other videos, but in case you haven't seen those, I did a quick recap of that process. Now, vitamin B6 can play a role in maintaining or keeping the cathepsins in the lysosome and reducing lysosomal membrane peroxidation. And that is because of vitamin 6, B6 supports a magnesium levels. Magnesium is critical because magnesium upregulates repair enzymes for the lysosomal membrane. So foods high in vitamin B6 can help, such as pistachios. Also, nutritional yeast has B vitamins as well. Also, resveratrol could put out the fire of the lysosomal membrane. If resveratrol is not there, then eventually magnesium will become deficient because magnesium doesn't put out the fire. It only repairs the membrane. If the fire is ongoing because of no resveratrol to put out the fire, then magnesium will forever be repairing the membrane, therefore leading to magnesium deficiency, and then no repair enzymes, and then the lysosome continues to be peroxidized, and then the cathepsins leak out, and then the exosomes are not degraded by the cathepsins. This is where iron also plays a critical role because it's supposed to prevent hypoxia. So HIF-1 alpha, hypoxia upregulates LOX, which is the cross-linking, and then MUC1 expression, also collagens, and fibronectin and integrins. And this creates a semi-permanent structure locking in the EPS matrix, leading to oncobiofilm formation. And then the oncobiofilm is established due to stiffened EPS, feeds back to reinforce tumor behavior. And then this also blocks immune infiltration because the ECM is super stiff, even increases drug resistance. So this goes to show that your diet, as well as proper vitamins and nutrients and preventing deficiencies, can have a huge effect on preventing these biofilms. So quick recap. Tumors, they secrete hyaluron, proteoglycans, mucins to create the first steps that leads to a future oncobiofilm, usually under hypoxia, which is low oxygen due to iron deficiency caused by ferroportin degradation, caused by hepcidin because of high IL-6. High IL-6 can be reduced with fruits. This allows iron trapped in macrophages to be exported so that this stops the iron deficiency that led to the hypoxia. Immune cells such as neutrophils and macrophages, they get trapped and end up secreting nets, also eDNA and even exosomes. And this also forms a stronger EPS forming steps towards a oncobiofilm. Oncobiofilms can be driven by exosomes. Exosomes drives the cross-linking that makes the biofilm rigid and stiff. A good way to reduce exosomes is to make sure that the MVB sacs containing the exosomes do not fuse to the plasma membrane. Instead, get the MVB exosome loaded sacs to fuse to the lysosome instead. That way, the tumors do not receive the exosomes and the tumors cannot create the biofilms with the exosomes. Vitamin B6 in pistachios and nutritional yeast can support a magnesium repair enzymes that are responsible to keep the cathepsins in the lysosome and to make sure the lysosome is not peroxidized. So that's it for the video. If you want more future videos, then like, comment, share, and subscribe. Keep it locked in here on my channel, and I'll see you next time.